Good day, everybody. I hope all of you are doing well. Today's lecture is about equations. Last lecture we talked about linear equations, how to solve them. You already are familiar with linear equations and the way of solving them. They are easy. Then later on we studied the quadratic equations. Quadratic equations we said are of the form ax squared plus bx plus c that's equal to 0. In general, these ones, when the highest power of x is 2, these ones are called quadratic equations. For quadratic equations, we studied simple quadratic equations that can be factorized easily and to be solved easily. For example, if you have got x squared minus 3x minus plus 2, that's equal to 0. This one is a simple quadratic equation that can be factorized. You know how to factorize it since we have got a quadratic form, so it changes into two brackets. For getting 2, we have got 2 and 1 to be multiplied together with negatives, since when we multiply those two we get positive 2, and when we add them we get negative 3. And when we have got such kind of factorization, we say from the formula that if you have got a multiplied to b, that's equal to 0, either a is equal to 0 or b is equal to 0. So from this idea we get that either x minus 2 is equal to 0 or x minus 1 is equal to 0. This one, when we are solving quadratic equations, it reduces to linear equations, and you're already familiar with solving linear equations, so that one will be easy. Here we get x is equal to 2 or x is equal to 1. So this one and that one will be solutions for that quadratic equation. What does it mean that it is a solution for that quadratic equation? That means if we put 2 into that equation instead of every x in that one, we will definitely get 0, and or if you put 1 into that equation, we will definitely get 0. That means these ones are equations. These ones are solutions for the quadratic equation that we have got. Then we studied another simple form of quadratic equations in the cases where we have got x squared, for example, that's equal to a number, let's say 5. How do we solve these kinds of equations? We simply take square root for both of the sides, okay? So that will be 5 under the square root. This square cancels that one, and x is equal to positive or negative square root of 5. We solved this kind of equation. Today we are coming to a new concept for you. It's called completing the square. Completing the square. Completing the square is also used for quadratic equations to be solved, but in this case, mostly when we are using it, the quadratic equations that we have got cannot be factorized easily, so we are using completing the square. What's completing square? If we have got a quadratic equation, x squared plus bx, so what do we have here? We have got the coefficient of x squared must equal to 1, then we can talk about quadratic equations, and then we have got that one is equal to c, a number, okay? Then what will we do to solve that quadratic equation, complete the square? We say x squared plus bx. What will we add here? We will add plus, okay? That b that we have got, we put it over 2, we divide it by 2 and square it. Every time for completing square, what will we do? We take that number that is in front of the x, we will divide it by 2 and square all of the term. Then and doing the same idea, the same thing for the other side of the equation. Why are we doing that? Because it's called balancing. If you're adding something to that side of the equation and not adding it to that side, it will be definitely wrong. So we have to add the same term to both sides of the equation. And then when we are doing like that, we will get a simplified form of an equation, of a quadratic equation, and can be solved in that way that we have solved previously. So let's move to the examples. In example 6, we have got the first one. It says solve that quadratic equation, x squared minus 8x plus 13. that's equal to 0. If you look at that quadratic equation, it cannot be factorized because for 13, the multiples of 13 is only 1 and 13. In that case we can never get -8 in the middle, so it is better for you to do the completing square. So what will we do? First we are moving that number to the other side, so that will be x squared minus 8x, that's equal to minus 13. Okay, so what's the first step we are doing? We are moving the number that we have got to the other side and leave the x's here. Then what will we do? Here we said we are talking about that number that's in front of the x. So we are adding 8 over 2, okay, to both sides of the equation that we have got. We said that we take that number that's the coefficient of x, we divide it by 2 and square it, and we are adding the same thing for both sides of the equation. From this one, what do we get? If you simplify it, we get x squared minus 8x. 8 divided by 2 is 4. 4 squared is equal to 16. So that will be 16, and this side will be minus 13 plus 16. Now simplify it, or let's say we factorize this one. We have already studied completing square, but in another way. Here we get x, and for getting 16 we get 4 and 4. Both of them negatives. Negative multiplied to negative becomes positive 16, and -4 becomes -8. So this is the factorized form. Look, previously we couldn't factorize it. Then when we did the completing square, we could factorize it. So that's why we are using completing square to solve a quadratic equation when it cannot be factorized, and change it to a factorized form. And minus 13 plus 16 is equal to what? Is equal to 3. Okay, now this one, since both of the terms are the same, so we will write it as x minus 4 squared, that's equal to 3. Since we have got a simple form, it is of that form, something squared is equal to a number, so it would be easy for us to take square root for both of the sides of the equation. That square cancels that one, so we will have x minus 4 is equal to plus or minus root of 3. Okay, so what is the value of x? X is equal to, this is a simple linear equation, that will equal to plus or minus, sorry, let me write the 4 first. I'm taking the 4 to the other side, so that will be 4 plus or minus root of 3, and that will be the result. What does that mean? If you expand it, that means x is equal to 4 plus root of 3, or x is equal to 4 minus root of 3. That is the solution using the quadratic, completing the square for quadratic equations. That was the first part of the example. Now we are moving to the second part of the example, part B. What do we have? Again, we have got a quadratic equation. It is 3x squared minus 12x plus 6 is equal to 0. If you look at this one, when we were talking about completing the square, we said the coefficient of x squared must equal to 1. Here in that example, we had no problem because we already had the coefficient of x squared 1. But here, if you look at that example, here we have got 3x squared. So first we have to get rid of that 3. Either you're dividing all of the terms by 3, or first you're taking this one to the other side, then do the division. But here, since we know that all of the terms are divisible by 3, so it would be easier for you to divide every term by 3. Okay, everything by 3. So 3 divided by 3, it is x squared, that will be minus 4x plus 2, and that is equal to what? That's equal to 0. Now if you look at this one, again, we cannot factorize it. Since plus 2 here, we have got the factors of this one are 2 and 1, and we can never get -4. So what will we do? We will use the completing square by taking the number to the other side and then doing the procedure. So x squared minus 4x is equal to what? Is equal to, here we have got -2. To do the completing square, we said we are looking at that number here. So we will have plus, we said we are dividing it by 2, and square it. And we are doing the same thing for the other side because we have to balance it. We have to do the same procedure, adding the same number to both of the sides so that it can be balanced. Okay, so here what do we have? We have got this one, 4 divided by 2 squared for both of the sides. Let's do simplification. X squared minus 4x plus here 4 divided by 2 is equal to 2. And then what do we have? 2 squared is equal to 4, and that one is equal to minus 2 plus 4 again. Here we can factorize it because completing square makes it easy for us to factorize a quadratic equation. To get 4, we have got 2 and 2 with negative sign. So negative 2 multiplied to negative 2, it is equal to 4. And negative 2 plus negative 2, that's equal to negative 4. Negative 2 here on that side of the equation plus 4, that's equal to 2. So here, since both of the terms are the same, both of the parentheses, so we say x minus 2 squared, and that's equal to 2. Now, we want to solve it. Since this one is a simple quadratic equation, we are taking square root for both of the sides. That square cancels that square root, so it will be x minus 2 is equal to plus or minus root of 2. Since we cannot take root of 2 out of the square root, so we will leave it like that. Now, since this one is a simple equation, simple linear equation, so that will be taking the 2 to the other side. Okay, that one to the other side. It will be 2 plus or minus root of 2. Or if you want to write it in another way, we say that the solution for that quadratic equation is equal to 2 plus root of 2, or x is equal to 2 minus root of 2. I just separated those two. So that is how we use completing square for solving quadratic equations. So what do we have to do? We have to the first thing that you have to do in completing square is to leave the coefficient of x squared as 1. Okay, that should be 1. And then we are adding the term, the coefficient of x divided by 2 all squared to both sides of the equation, and then we do the factorization and solving it easily. Now we have got another way for solving quadratic equations. So how many ways have we studied previously? We have studied quadratic equations that can be factorized. Okay, quadratic equations that can be factorized easily. Quadratic equations that are simple. We have got quadratic equations. Of course, these ones are special cases of all of the other quadratic equations. Then we have got completing the square. We already studied completing square. And then now we are studying the quadratic formula. What is the quadratic formula? You're already familiar with quadratic formula. You have studied this one, familiar with it. So what is quadratic formula? And when can we use it? Quadratic formula. Whenever you have got any quadratic equation, okay, ax squared plus bx plus c, any case, this case, that case, or in the completing square case, doesn't matter. So this quadratic formula can solve every kind of the quadratic equations. It is the general form for finding the solution for quadratic equations. These ones are special. Those two are special cases, and this one is another way of solving quadratic equation. So whenever we have got something like that, if it is the quadratic equation that we have got, if it is factorized or not factorized, we can solve it by that rule. The rule is called a quadratic formula. That's what it is: minus b plus or minus b squared minus 4ac under the square root and all over 2a. What are those alphabets? You know that b is that b, the coefficient of x. Again, we have got b squared minus 4 multiplied to the coefficient of x squared multiplied to that number that we have got here and all over 2a. So that one is called a quadratic formula. It can solve every kind of the quadratic equation that we have got. Either it is solved easily, factorized easily, or not factorized easily, you can use that one. So this one is the general formula for finding quadratic equations. Let's move to the examples that we have got. We have got example 7. The first part, we have got 3x squared minus 5x minus 1, and that's equal to 0. So whenever we have got a quadratic equation and it is required from you to find the roots, okay, we say find the roots. What does it mean, find the roots? It means find the solution. Find the roots for that quadratic equation. That means find the solution, find the x's that are given in here. So how do you find the roots for that quadratic equation using quadratic formula? We have to identify a, b, and c in that equation. So what's a? A is equal to the coefficient of x squared, that's 3. B is equal to the coefficient of x, that's minus 5. And c is equal to the number that we have got here, it is minus 1. So these ones are the coefficients, the numbers that we have got. Now we are using quadratic formula. So x is equal to what? X is equal to minus from the rule and then multiplied to b. What is b? B is minus 5. Okay, then we have got plus or minus from the rule. Then we have got a root from the rule. Okay, then we have got b squared. What is b squared? I have got minus 5 as b and I square it. Then we have got minus from the rule. Then we have got 4 multiplied to a. A is 3, and that's multiplied to what? Multiplied to c, that's minus 1. Okay, so that one is the numerator of the quadratic formula, and the denominator is 2 multiplied to a, which is 3. So now let's simplify this one. Minus minus 5 is 5, plus or minus, that one becomes 25. 5 squared is 25, minus 4 multiplied to 3 is equal to 12, multiplied to minus 1, it becomes positive, minus minus becomes positive 12. All over what? All over 6. So if you simplify this one step further, what do we have? 5 plus or minus 25 plus 12 is equal to what? Is equal to 37, and all over 6. So this one is the required result, the required root, the required solution for that quadratic equation. What does that mean in here? That if I separate it, that means x is equal to 5 plus root of 37 over 6, or x is equal to what? One of the x's is this one of the roots, one of the solutions is this one, or x is equal to 5 minus root of 37 all over 6. So these ones are the roots, but here we have written it together. That was what? That was the quadratic formula used for solving, for finding the roots, the solutions for the quadratic equation. Okay, so what's next? We have got the same example, part B. It's given another quadratic equation. So what is it? Part B. It says find the solution for that quadratic equation, which is 4x squared plus 12x plus 9, that's equal to 0. How do you find the solution for this one? Again, using quadratic formula, we have to know, we have to identify a, b, and c. A is equal to coefficient of x squared, which is 4. B is equal to 12, and c is equal to 9. Okay, so how do we do that again? Here we have got the rule. We have got x is equal to, we have got minus b, so we have got minus b is 12, plus or minus from the rule. Then we have got b squared, which is 12 squared, minus from the rule. Okay, minus from the rule. Then we have got 4 multiplied to a, which is 4, and then multiplied to c, which is 9, all under square root. Then all over what? All over 2 multiplied to a, so 2 multiplied to 4. Let's solve this one. X is equal to what? Simplify it, minus 12 plus or minus. Here we have got this one is equal to 144. 12 squared is equal to 144. Then we have got this minus 4 multiplied to 4 is equal to 16. 16 multiplied to 9 is equal to 144. Okay, 144. All what? All under the square root, and all over 2 multiplied to 4, that's equal to 8. If you look at this one, in that case, here we have got both of the numbers are the same, so x is equal to minus 12 plus or minus 0 over 8. Simplify it one step further, so x is equal to minus 12 over 8. Minus 12 over 8, both of them are divisible by 3, okay, by 4, sorry. So that one divided by 4, and divide this part also by 4, we get what? We get minus 3 over 2. So that is the only root, the only solution. X is equal to minus 3 over 2 is the only solution for that quadratic equation. Here, if you look at that example, in that example, what is the difference between the first one and the second one? For the first example, we had under the square root was positive 37, and we had two different solutions for that equation. But here, when we solved it, under the square root is equal to 0. Okay, look under that square root is equal to 0. Since it is equal to 0, we get only one solution here. When the discriminant, when the under square root is equal to 0, we get only one solution for the quadratic equation that we have got. So here we have got 2, we got 2 solutions, here we got one solution. Let's move to the third example. The third example that we have got is part C. It's written as x squared plus 2x plus 2, and that's equal to 0. Okay, x squared plus 2x plus 2, and that's equal to 0. Again, we have to solve this one using quadratic formula. A, the coefficient of x squared is equal to 1. B, which is the coefficient of x, is equal to 2, and C is equal to 2, the number that we have got here. So x is equal to what again? Again, using the quadratic formula, we have got minus b, minus 2, plus or minus, plus or minus, under the square root, what do we have? We have got b squared, so that one is 2 squared minus 4 multiplied to a multiplied to c. This one is c. All over what? All over 2 multiplied to a, which is 1. Let's see what will we get from this one. We get x is equal to minus 2 plus or minus. That one is 4 minus 4 multiplied to 2 is equal to 8. So we have got 4 minus 8 over 2. So x is equal to minus 2 plus or minus 4 minus 8 is equal to what? Is equal to minus 4 all over 2. If you look at the under the square root, what do we have? We have got something that you already know, it is undefined. We have got a negative number under the square root. Since we have got a negative number under the square root, what do we say? We say that the equation that we have got has no real root, because this one cannot be solved on real numbers, has no real roots. Okay, so we are leaving it like that. Whenever you see a negative number under a square root, since you know it is unsolvable on real numbers, so we say that we cannot solve this one on real numbers. Since we cannot solve it, we cannot find this, the value for x, the solution for x, so we say it has got no real roots. So if you look at the three examples, from the three examples, what do we get? We get three cases. What are the cases that we have got? The first case is that when the discriminant, when the under the square root is a positive number, we get two real roots for the quadratic equation. The second case is that when the under the square root, that square root that we have got here, it's called the discriminant. Okay, that square root, that part is called the discriminant. When this one is equal to 0, we get only one solution for the quadratic equation that we have got. And the third case is that when the discriminant, the under the square root, okay, is called the discriminant. The discriminant is a negative number. We say that it cannot be solved on real numbers, so the quadratic equation that we have got has no real roots. So here we have got three cases. Let me write it down for you. When we have got discriminant, okay, let's talk about discriminant. We said, what's the discriminant? It's the number that's under the square root. What was the formula of under square root? It is b squared, okay, minus 4ac. That's equal to what? We will call this one as d. Discriminant is equal to the part that's under the square root. It's called discriminant. Okay, so if d is greater than 0, so when it is a positive number, then the equation has what? Has how many roots? Has how many solutions? Has two real roots. Okay, when it is positive, when we get a positive number, so we get two different roots, two different solutions for the quadratic equation. How about if you have got d is equal to 0, okay, if the discriminant, that one, if you did it, that's equal to 0, like we had that case in that part B, then the equation that we have got, the equation has how many roots? Has only one root, one real root. If you look at this one, discriminant is equal to 0, under the square root is equal to 0. So we got only one root, one solution for the equation, quadratic equation that we had. What is the third case? The third case was that when we have got d is a negative number, that means the discriminant that we have got is less than 0. Okay, then the equation that we have got has no real root. Okay, since we said we cannot solve it on real numbers, so we say that the equation, the quadratic equation that we have got has no real root. Three more examples are given for the discriminant case. In example 8, what do we have? We have got part A. The requirement for the example is that to determine how many real solutions the equations have got. So in that case, you're only finding the discriminant. So part A, we have got x squared plus 4x minus 1. It says determine, use discriminant, okay? Use discriminant to determine the whether the equation has got one real root, two real roots, or has got no real roots. So here, since it says use discriminant, you're only using this part of the quadratic formula that you have got. You're not finding solution, you're just describing whether it has got roots or it doesn't have any root. So you're not solving it, you're not finding the x, you're just showing whether it has got roots or not. So since it is, we are just using the discriminant, so it will be easy. Here we know that a is equal to what? A is equal to 1, b is equal to 4, and c is equal to negative 1. Okay, negative 1. So b squared minus 4ac is equal to what? B squared is equal to 4 squared minus 4 multiplied to a multiplied to c. So that one is equal to 16 minus 4 multiplied to minus 1, that's plus 4, and that's equal to 20. Since 20 is greater than 0, okay, so it's the first case, so the equation that we have got then the equation has got two real roots. We're just saying that it has got two roots, but it is not required from you to find the roots. You're just determining that it has got two roots, but you're not finding them. Be careful of these kind of questions. So part B, what do we have? We have got 4x squared minus 12x plus 9. 4x squared minus 12x plus 9. Again, here what do we have? Here we have got a is equal to 4, b is equal to negative 12, and c is equal to 9. Here again, we are using discriminant b squared minus 4ac. That's equal to what? B squared is minus 12 all squared minus 4 multiplied to a multiplied to c, that's 9. That one is equal to what? 144 minus this one altogether is 144, so that one is equal to 0, which is the second case. When we have got the second case, what do we say? We say the equation, okay, has one real root. So you're just determining that it has got one root, but you're not finding the x because it's not required from you. Part C, what do we have for the equation? We have got 1 over 3 x squared minus 2x plus 4 is equal to 0. Here a is equal to what? A is equal to 1 over 3, b is equal to negative 2, and c is equal to 4. Again, discriminant is equal to what? Discriminant is equal to b squared. B squared, it is minus 2 squared minus 4 multiplied to a, which is 1 over 3, multiplied to c, which is 4. Here we get minus 4 over 3, which is less than 0, which is the third case. So it has got what? It has got no real root. Okay, you're just writing it has got no real root, because when we are solving this one, we get under the square with a negative number and we cannot solve it. That's all about that section. So we have, in that section, we studied equations, linear equations and quadratic equations. Linear equations were easy to be solved. And then for quadratic equations, we used some different ways for solving them. Quadratic formula, completing square, simple quadratic equations when we have got them, and we have got the equations that can be factorized easily. So that's all about that section. Thank you for listening.